Okay, hello and welcome. What we're going to do today is we're going to download a template, if you like. It's a couple of files that I've made so that you can mess around, you can get into the easier for doing your own little graphics. So we're going to download that from a repository, and we're going to then tinker with that a bit to make it a bit of a demo for ourselves. Okay, so I will post the URL for this repository in the comments. And once you go onto it, you will see uh, this repository here. So what you can do is you can either clone the repository, which means that if there's any changes made to these files, you'll automatically get them. Or if you don't want to clone it, you can hit the dots here and you can hit download repository. Once it downloads, it should download to wherever your default download folder is. I'm just going to drag mine over to here. We can minimize that out of the way for now. So here it is, and it comes down with this sort of name. You can stick it anywhere, but what we're going to do is I'm just going to change this name of the zip file. Sorry, just say demo. And you can put it anywhere. I'm just going to leave it in my downloads because I'm just going to delete it later. And we're just going to extract it. In this case, I'm going to extract it to the downloads folder as well. So that pops in here. If we open it up, we'll see it has this name which goes back to my repository. I'm just going to change that again to demo. And inside this folder, if we look inside here, we see there are several files. There is a hidden file called .vs code. Now, normally you wouldn't track this in Git, but it's quite handy because in this file is a folder called arduino.json, and this controls and this contains stuff like the serial port, and it tells it where to build the file to. It also says I'm using COM port 7 and what type of ESP I have. So it's quite a handy file. I'm just going to close that there. So we have this folder structure, and what we're now going to do is we're going to open this folder in VS Code. So I go into VS Code and find the open folder. This will bring us to, now I know I put it in my downloads, Phil's demo. And the one we want is this one here, the one that's at the same level as, or the parent of the VS Code. We don't want to go into that. So it was Phil's demo and then it was demo. So we select this folder and this will open. Yes, do I want to trust myself? So this is going to open up our source code and we can see that is over here. And the files that we have in this is the main.ino, and all that does is it just sets up. Now, come back to it, we've got some red squiggles here, so it will actually compile. But so this will be our own little file, and it's a stripped down version of the factory one so that you can get started straight away. There's a folder called GUI.h and GUI.cpp, and there's a display H and a display.cpp. Again, this is showing red here because it doesn't know where that include is. So all I've done with the factory one is I've stripped out the display setup for this, because we're not going to change this around. This is going to be static for board fell on the ground for this board. So that is going to be for that board. So we don't need to change it. So I've broken it out from the main.ino. And I have this GUI-H and GUI-CPP. And this controls the files so that are not the files. When we press the buttons, it cycles through the different screens. It's no harm in just checking a build on this, and we do that by going to the main.ino and we hit the verify. And I've been messing around with my board, so I'm actually going to squirt this down to it. If the builds are going to take too long, what I'm going to do later is I'm just going to pause them and come back after the build. Usually the first one will take the longest, but we have specified in this Arduino, sorry, in this VS Code, arduino.json, this is a build folder, which is this build folder here. So as stuff changes, it'll keep these files here, which will speed up our future builds. Did I actually press verify on that? I think I did. I thought I did. Well, let's just, in case I didn't, let's just go back there to the .ino. As I said before, I'm actually going to clear that because I do like clearing it because you then know that's problems. It's going to go. These can't find these paths. I'm going to leave that build there. I'm going to leave that build and I'm going to come back after it's built. Okay, so that built away, and you can see it's how much memory it is. I suppose we'll address the red squiggly lines. So what's after happening is here is it's saying Visual Studio Code is saying, hey, I can't find those include files, but obviously it can when it digs down deeper. And that's because Visual Studio Code uses this IntelliSense. So uh, and that's so that when you type and it comes up with the methods that are in the objects and that, and it just helps you speed up stuff. But just because it thinks it can't find the files, when it actually goes to build and compile, it generally can. The easiest way to now, if you hover over here, you'll get a prompt, and it'll say edit include path settings, and you get this one up here. Now, what that does is it creates a JSON file, and then you can come down here and you can add the files that where your libraries are. Now, I actually don't like editing this. The first time you open it, it does create this file here if this hasn't been created. So what I like to do is I like to close that, and I like to directly edit this. So this here has our include path and our workspace folder. So this shows us it's looking in our workspace, but I haven't added the includes to there. So what I need to do is we need to add in the other libraries. So this is specifically the first error it's looking for. It doesn't know where the Arduino libraries are. Now, in my case, and this is different for possibly you, because you may have installed your Arduino libraries to a different place, but I've stored them in a folder called Arduino IDE, Arduino, and libraries are here. So here are all my Arduino libraries. So what I'm going to do is I'm just going to right click on any one of these. I'm going to go copy as path, or you can copy as text or whatever. So I'm going to go copy as path, and I'm going to come in here, and I'm going to, so this JSON, so it's a new line. This was the last line, so I must put a comma. And if I put that in there, there's my path. Now, I don't put a comma. If it's the last entry between two square brackets, I don't put a comma. Now, it's giving an error here. And it's giving an error here because Windows defaults to backslashes as the separator between file names. However, backslash is what's known as an escape character. And an escape character means, hey, ignore the character after that. So it's getting a bit confused. It doesn't know what to do. So there's two things you can do here. You'll notice it has, in the one above it and the one over here, it uses the slash to the forward slash. So you can either change all these to forward slashes, and that will accept that fine. And there they go. See, it's gone green. Or the thing that we could have done, and it's purely up to you, is you can escape the escape. So the slash means ignore the next character. So if you actually go escape, escape, so go backslash, backslash, that tells it to ignore the escape of the escape. So it's escape and the escape. Okay, so whichever way you want to do. What makes probably more sense when you're reading it again is to go the forward slash, but it's quicker to do it this way. Now, we don't want this robot motor library on its own, so we want all of the files in the folder in Arduino.ie called library. So we put it in a double star. And that's all we have to do. And we go save. And now when I go back to my .ino, majority of the files the red squiggles are gone. Okay, so this one is saying, hey, I've got an issue. Now, it doesn't necessarily mean it's an issue with display setup. If we go into display setup, we'll see what the issue is. And the issue is that I can't find three other folders. And that's our file include files. That's because they're not in the Arduino one. These are files that belong to the Expressive esp-idf directory. So we need to find that. And again, this will depend on where you've saved yours to. Again, my install was esp-idf, and that's in the D drive. And this is looking for, they don't call it an esp-idf, they're called components because the way they're added in their own IDF. So we want to add all the contents of this components folder. So again, what I can do is I can just come in here and I can go say copy as path. Then what I do is I go back into my file here. Again, I want to put it in here, paste it, and it's a comma because it's another entry, it's not the last entry. And we don't want the README file. What we want to is we want all of the contents. So what I'm going to do this time is, the last time I used the escape, this time I'm going to change them to the forward slashes, just to show you that this also works perfectly well. So now we're telling it include all the contents of the components directory. That's what the double star is telling us, they're wildcards, and look for there for IntelliSense. I'm going to make sure I save that, and I am going to close that down. And what should now happen is when we go to the .ino, there should be no more squiggles. And you can see display set, well, when I say no more squiggles, there's plenty of squiggles here, but don't worry about them for the moment. We go into the display setup, and we'll see that it's quite happy with all its includes. Right, so what we've done is, nothing really. We've just got rid of some squiggles that weren't even stopping us from our build. But what we want to do is now we want to add in some extra little display functionality on our board. So if I go back to the .ino here, I'm actually just going to re-download my own because I have been messing around. I have changed it since we last saw this. And I'm just going to pause and come back when that has flashed it to the chip. Okay, so that has flashed back to that one there, and the right one here. As I flick through this button here, all it does, you can see that there, is it flicks between two different display pages. There's our flashing LED one, and this one here, which is showing our battery voltage. Yeah, showing battery voltage. Or no battery voltage, so it's showing our actual USB voltage. Okay, so what we want to do is we want to create a third screen. So there's two at the moment. We have the virtual LED and the other one. So if I go into my GUI here, let's close that down here, and I'm going to split the windows just so that I can actually put my there. So I have my header file here, this one, and I have my GUI one here. And this one I've said, hey, there's two pages, LED page and the other page. So we're going to increase that to 3. And that's just a little bit of error checking in case the button is pressed too many times. So what we're going to do is we're now going to have a look at this. So this is our, now you can see there's some of these ESP ones. So there's another library somewhere that hasn't been included, but we won't necessarily go digging for that now unless we have to. So when we come in and press the button, we call this method here UI switch page. And what it does is it says, so it says it starts off with this value n, 0, so it's on page 0, and then every time we press the button it increments n. And it says if it's equal to the page count over here is 3, then it resets to 0. So it goes 0, sets 0, and then goes in increments 1 and 2. So we have 2 pages. So what we're going to do is, so we don't need to change that because we've changed the page count here to 3. And what we're going to do though is we're going to create a new page. So we have a page here. This was the page that has our LEDs. And we have page 2, which shows our battery voltage. So what we're going to do is we're just going to go down here and we're going to create page 3. So page 3. And what we're going to put down on page 3 is we are going to use something from the LVGL's library. So I'll just open up this here. So if you type in LVGL, you get their homepage. And there is their homepage, lvgl.io. And in here, there is a folder called docs, which tells you documentation. And there's a lot of different helpful things about the library, but we can see this one here is one we're going to use. And this is widgets. And here are all the different types of widgets and the graphic pre-built little scenes, or actors or scenes and everything that you have. You can see there's canvases and there's the LED ones that I was using in the other one. But one of the ones I want to have a look at this one is a meter. So there is a little meter, and it can be a bar, linear meter, or it can be like a dashboard, rev counter meter. So we're going to do that. And there's an example in here. And if we go into example, you can see it's a simple meter. So we're going to have a look at that, and it says show the C code. So we're going to look at this, and here is the C code for it, and it does an animation. So what we're going to do is we're going to strip out the default meter here, and we're going to put that into our own code, and this will be our page 3. So this bit here is the setup of the meter. That's all it does. Is this is the initializing of the meter. This is run once. What then happens with this one, it does an animation, and that sets up a callback. We're not going to be using that. I'm going to do something a slight bit different with that. So, but we are going to we're going to use the meter example here, and we're going to copy that. So I've taken everything from where it says meter down to added line, needle line indicator. So we're going to copy that and we're going to pop that into our page 3 here. Now, it will give it a little better. That's not going to run straight away. Because I'm also missing the letter M. So I'm not missing the letter M. Don't know why it didn't come across there. But anyway, I am going to put that in there. So meter. Oh, I aren't missing the letter M. I don't know what happened there. That was a bit weird. Okay, so it's creating the meter. Now, so it's creating this object, this actor, if you like, based on this scene here. And it's going, let's compile that and see what happens. So to compile, go to the INO, hit the verify button. So this is the setup for the graphic. It's not going to do anything else with it. It's just going to render the graphic on the screen. And we'll have a look a little bit inside in that there once it's built. Now it's given an error because it doesn't know what this meter is. So it's saying, yeah, okay, you've said this meter, but you actually haven't defined it at any stage. And if we look at our code, the reason for that is because up out of here, it's actually saying, hey, make a static object here called meter. So we need to create an instance of the object. And we're going to stick this up in our GUI right at the outside here with all our other static stuff. So remember, static means it can only be used in this file. It's like C's old version of private member variables. So there's the static one there. So that's given a warning about that. I'm going to clear this just because sometimes you can miss your errors. Okay, so I'm going to hit build and I'm just going to pause while it builds. Okay, that's come back. There's no issues. I'm going to download this now, and it's not going to run the way we expect it to run. Just warning you that. So that has uploaded, and as I said, I was expecting that to not work the way we did. But look, there is a nice graphic of a display, and the bottom of it's there. So I'm just trying to find where the button is. And if I toggle through it, you'll see it actually is overlaid on top of our other pages. So it hasn't. It's not changing. It's not changing the way it should be. And remember the way I was saying, think of this as you have a stage and you build scenes and then you attach actors to the scenes. What's after happening is we've attached this graphic to the stage and the scenes are behind it. So it's always on, irrespective of what scene we're displaying. And the reason for that was because, well, we just copied and pasted our code from the help file or from the example file. And if we look at the other ones, and I even called it stage here was scene, we created a scene here and we attached the scene to the stage. If we come down to page 3, what we've done is we've created this actor, but we're actually attaching this not to a scene, but we're actually attaching it to the stage. So what we need to do is we need to come up and we need to create a new scene. So I'm going to take this last one here and we're going to call it scene 3. We're going to give it an index, the index of 2. And now we've attached scene 3 to the stage. The stage is attached to this tile. So scene 3 is our magic word here that we need to come down to page 3. And instead of attaching our meter to this, which essentially is attaching it to the stage, we attach it to the scene 3 in this case. So now when I build that, it will come up as page 3 and it won't be overlapping our existing one. So I'm going to save that and I'm going to download that to board. And again, I'm just going to pause while it does that. Okay, so that's just finishing up the last bit of an upload. And it's done it there. They should have rebooted it and it's gone back to, now we have our LEDs. And as I toggle through them, there is our battery volt one and then there is our meter. But it's static. Now it is exactly as it was rendered in the configuration for it, but it doesn't do anything. So we're going to get the needle to move. Because if we look at this, what we've set up on page 3 in the setup on page 3, we've basically created a meter, we've created a scale on it, we've created this reference for the indicator, which is the arm, and then we've basically given the colors, and you can tinker around with all of these. And there's the indicator has been added, the needle. So what we want to do is we want to make the meter increment around. We're going to start at 0 and count up to 100. And we're going to do that as a timer. So we've already got 3 timers here for these LEDs. Well, let's create a new timer. So we need to create a timer, and when the timer fires, it's going to call a task. So we're going to create a new task up here. It's timer, so let's call it timer task 4. So this is the task that's going to be called, and now let's create the timer. So the timers are down here, so let's copy this. These were the 3 ones that control the LED. Let's pop it in there, and we'll call this one timer 4, and it's going to call task number 4. And this is every 1000 milliseconds. Well, that's a bit slow. So let's put this at 200 milliseconds. So 0.2 of a second. So at 0.2 of a second, now here's the other thing as well. What are we attaching this timer to? Well, we're not attaching it to LED 3 because that wouldn't make any sense. We are going to attach this to our meter object here. So this is what we're attaching that timer to, our meter. So what's going to happen is the timer is told to run on this object here called meter. And every 200 milliseconds, it makes this timer task be run. This launches is going to run this little method here. So you can see here are the ones for our LEDs, and all they did was they inverted the LEDs. So what we're going to do is we're going to copy one of these. You know what? We're going to use hardly any of this because we're not going to use that at all. And what we're going to do is we call it timer task 4, and it's going to pass a reference. We're not going to use anything with that reference. So this will be called every 200 milliseconds. And what we're going to do is we're going to create a counter that goes from 0 to 100 because that's our scale on this. So we will start up here. We will create a static integer called meter level, and we're going to set it to 0. So we have a variable that we can access anywhere. So what we're going to do is we are going to increment it, and we're going to test, and if it equals 100, we're going to reset it to 0. So it goes 0, 1, 2 up. So we're going to do a pre or post increment. So we're going to increment it, and then we're going to test it. So if meter level, I thought I capitalized. Did I not use camel case notation? No, it's all lowercase. Doesn't matter. If meter level equals to 100, then what we're going to do, meter level equals 0. Okay, so that's going to count up. It's going to have 100 different intervals. So that's great. That's fine. The counter is counting up. But what else is it going to do? Well, what we need to do with that, and you know, it's no harm that we just run a little bit of a compile and a verify on that, and make sure that compiles okay, that we haven't forgotten anything. So what's going to happen is we've created our object, we know that works, our meter object, and now we've started a timer every 200 milliseconds. It calls the timer, it increments a counter. If the counter hits 100, it resets it to 0. Otherwise, it's going to it's going to use that value to increment the needle of the pointer. So, and that's compiled fine. So what we need to do is we need to call, there must be some method somewhere that we need to indicate the update the pointer on the meter, and this is it here. So it's LV meter set indicator value, and what you need to pass into it is the address of the meter itself, as in this dial here, the indicator, which is the indicator bar, because you could have more than one. This won't restrict you to just having one indicator, so there could be more than one, and the V is the value. So let's copy this out here, and so this is the method that comes from LVGL library that we're going to need to use. So we're going to now, after we've incremented that value, we need to do that. Now it's thrown a couple of errors because it doesn't know what the pointer is, the reference, the needle pointer, the pointer to the needle pointer, and it doesn't know this V, which was the value. Well, the V in this case is meter level, so that's fine. But we need to give the reference to this.
So we've obviously created this indicator bar because it's displayed on it, but it doesn't know it. It has no reference to it. If we scroll back up here, we can see, hey, this indicator level has been referenced everywhere. It does exist, and it says indicator level meter add, so it's there. But the problem is we've defined this pointer, we've created this object here, but we've created it as a local member to this function here, the UI begins. So we need to make this available to the other methods. So that's quite simply, we can pull this out from here. We can control X that, and we'll stick it up the top here. Now it's going to be only, we'll stick it down here with our meter level, it's only going to be usable by this file, this object. So we'll stick it in here. So there we are, we're creating the level meter indicator, and we're calling it indic, and this is now will be accessible by all these. These still won't have a problem with it here. When the timer is called, when it's incremented, it will, and you can see the squiggle line has gone from there. So we can now expect to see this as count all the way up. So let's have a look at that. Go back to our INO, verify that. Okay, so that verified fine, and now I'm going to download it to the board. Still showing the other one. Again, I'm just going to pause while it's doing all that. Okay, I just started there. It's doing the last bit of the download. It's at, and it's done. Okay, so now we have our meter. Again, it defaults back to page 1, which is our LEDs. Flick through, there's our battery stuff, and now it should go on to our meter. And you can see the dial. I hope you can see that there. What I'll do is I'm going to bring the camera over. I'm going to pause it and bring the camera over to that. Okay, so there we go. Just try and keep it focused. It's counting up, and it goes from 100, and it's going all the way back around. Or so what we could have done is we could have done a nice thing is when it reaches 100, it starts decrementing, so the needle goes up and comes back down. But yeah, we could do this to death on this one. But at the end of the day, this is just to show you how using this sort of template here, we can really get objects up on that graphic very quickly. So I suppose the takeaways from this are, again, what we need to is we can go on to the LVGL documents and their examples and go on to their widgets. Have a look at the source code. You can take any of those examples you want, or there's ones for drawing squares. You can put them in to the UI setup function there as a new page. You can mess around with them, toggle around with them, do different bits and pieces with them, and get nice little graphics going up really quickly. Okay, so hopefully you find that of some sort of use. And yeah, stay tuned. Talk to you next time. Be good.